Hi, I'm Edward Miller. This is a short video to show you how eValid can be used to identify and ultimately prevent penetration testing on a web application. Now, those of you working in the computer security field are probably aware that penetration testing can occur a large number of different ways. And what we're going to emphasize today is just the way eValid is used as a tool to identify an exploit, the possibility of exploit, and the fact of an exploit. Now, to do that, I've got a very simple example here. And in fact, the simple example is this HTML right here that you see on the screen. Now, if you look at that HTML, you're going to say, who coded that? And you'd be correct, because this is extremely ugly, impolite, inappropriate HTML, and I can tell you that if you try to load that HTML in your browser, be prepared for the browser to do some very unusual things. So the purpose is not to have your browser do unusual things, but to have a website which does illustrate the possibility of a penetration. So when I render that page, this is the kind of result that I get. So that's this HTML rendered on this page. Now, we didn't actually render it. That's actually a screenshot, and for reasons that will be clear. So there's the way the page actually renders. If you go ahead and click that button, obviously I can click on the picture of the button and that doesn't have any effect, then what happens is, because of the way this particular page is coded, and if you're into this, you can look down here on the bottom and you can see how this is done. But remember, the purpose today is to show you how to check these kinds of things, not to show you how to do them. If you do run the web page and click the button, this is what happens, and you get hacker sites showing up on the screen when you didn't expect that to be there. Now, again, let me emphasize, this is a very ugly piece of HTML, but eValid can handle that because, of course, it does wind up being downloaded over the wire into the eValid browser. And now our test plan is going to be the following. We're going to basically, first off, use a play value, and I'm referring, by the way, to a test script, which is at the bottom of the page here. And I'll come back to that. I'm going to concentrate now just on this particular sequence of actions. In fact, let me go down and show you. It's probably better to show you in the scripts. Let me do it that way. So in the script, we're going to go to the demonstration page. That's this part here. That's this page before we get to the hacked version. The first thing we're going to do in the test is validate that the page was actually served from the correct domain. Now, this is actually served from one of our domains. As you can see, it's a eValid penetration test examples. But in the real world, you'd want to make sure that the domain from which the page was served in the URL contains at least mydomain.com. That's a first step. And secondly, you want to confirm that the actual complete web page is the one that you're looking at. And you can do that with two commands in eValid: to confirm part of a URL and to confirm the complete server. If you put the HTTP for the full server for the URL for the page and run a validate document server command, eValid will throw an error if the page doesn't actually come from where it is you expect it to be coming from. The next thing is, we're going to look into the page, and I'm going to give you some hints back here in this page. The error that's going to be manifest is the result of fooling around with the JavaScript in this link command. So next we do in the script a sequence called, this is a structural test that examines the current DOM of the page. And the first thing we do is we locate the element that contains the iframe, the tag name iframe. Once we know we're in that element or near to it, then we know we can run a second index find element command, which will start at that index and below. And now we want to confirm that a particular that the inner HTML of that particular element contains both the phrase rel and the phrase style sheet. So what we've done is we've confirmed we're in an iframe. There's the iframe, and below it, there's the link for that iframe, which says that it's a style sheet. And right here is where the cross-site scripting occurs, and that's what induces this penetration. Okay, so once we've done that, then the next thing is, in the playback of this test now, we've identified the specific source index. We don't know what that is, and we don't want to be specific about it because it could be any one of a different any location on the page, and the page, if it was hacked, could have a completely different structure. So we want to do this in quite general terms, but now the source index points at a particular value, and we're going to extract the current value of the full source of that element. That's getting the entire source of that element, and we're going to save that in a string called current value. Now, what should happen is the current value should match the should be value. So we're going to compare the contents of a previously described string called should be text with the contents of current value text, the one we just received from the page. And that comparison should match exactly. All right, now, when we play the script back, indeed, we get a red screen showing that an error occurred, and that is because the page had been hacked. And if we look at the playback summary, we see that the test ran to completion. There was one warning, but there are actually 4 errors that resulted. So the number of errors shows there. Whoops, number of errors shows in there. And then lastly, let's look at the actual index event log of this penetration test as it plays back. Now, the event log uses, in the left-hand column, milliseconds, and the second column is is a count between that command and the next command. So 68 minus 60 equals 8, and 77 minus 8 equals 9. And then this last one is the total. So we see that we're searching downward for the match on rel and style sheet, and we make a total of 4 attempted matches. 4 matches are found of 8 attempts. We find a paired match at index 15. So we set the source index to 15. Then we do a value get element, a value save, as the script indicates. And then here is the match string, and the comparing the strings, and we see the comment here, base and response string differ. That causes a failure. All right. The event log will now show a failure, and as a result of that, you get this red screen that we saw, the red playback summary, just like that. Now, here are the actual responses. This is what we got. No, pardon me, that's what we should be, and this is what we got. It should say mysite.com, myxxs, and in fact, somebody, the bad guy, has hacked in this address. Now, the points being made in this illustration are that for a sophisticated website, including ugly websites that are badly coded, and it's a tribute, by the way, to the skill and the sophistication of the rendering engine, that the rendering engine can make sense out of that kind of ugly HTML. But what we're illustrating is that eValid can detect the possibility of and the fact of a hack on a web page entirely automatically. Now, that's fine, and you say, well, how do I apply this in practice? And the answer is you have to run this test on lots and lots of different pages looking for this particular kind of error. But that's relatively easy to do. There's a mechanism in eValid to run a test parametrically, or to run it repetitively, or run it for every web page in a website, that kind of thing. So the main point here is to illustrate that eValid as a tool is able to deliver the kinds of analytic searching of the web page and retrieval of critical data that's required for detection of this class of penetration tests.